Okay, we now come to classification. Classification is actually a very old problem. It has been tackled since the times of AI, and probably it became quite popular in around 1960s, and since then lots of people have been working on this problem. So here is an example of this problem. Basically the problem consists of, given different records, can you classify these records into a set of predefined classes? Okay, so in this example, just to illustrate, this is an illustrative example. So here you have a data set, you have different records, and each record is giving the status of the weather at a particular point of time. For example, the first record is telling that the outlook of the weather is sunny, the temperature is 75 degrees Fahrenheit, humidity is 70%, it is windy, and given these weather parameters, the last column, which is called as the class column, it is telling whether this weather condition, is it a nice weather to play outside or not. Okay, so basically to play, let's say, tennis or cricket outside. And for the first record, it says, yes, this weather condition is a nice weather to play outside. Okay, and the second example says that it is not a good weather condition to play outside, probably because the relative humidity is very high, the temperature is very high, and so on. So it's not a very nice weather to play outside. Okay, so now given certain example records like this, which tell that for a given weather condition, whether it's nice to play outside or not. Now, if we are given a new weather condition, we want to be able to predict whether that new weather condition, is it nice to play outside or not. Okay, so we are given examples and we want to use these examples in order to predict for new records. Okay, so in order to do that, what we need to do is we need to model the relationship between the class labels, which is basically play and don't play, two labels, and between those labels and between the attributes. We have 4 attributes here, excluding the class attribute. So what is the meaning of relationship? Here is one example. There are different kinds of relationships, and this is just one of the examples. Here you have, for example, if you look at these 4 records, you will be able to come up with a rule of this kind. In all these 4 records, you have the outlook column to be overcast and the class column to be play. Okay, and in none of the other records do you have the outlook column to be overcast. Okay, so by looking at these records, we can easily infer a rule of the kind that if the outlook is overcast, then the class is equal to play. Okay, so given a rule of this kind, we can easily, when we are given new records, if a new record contains outlook as overcast, then we can easily predict that, okay, this is a nice weather to play outside. Okay, given this rule. Okay, so this is the task. We need to mine rules or some other model from this, some model that captures the relationships from this data set, and we need to use that model in order to be able to predict for new records what is the class column. So this is an illustrative example. We have first a set of examples. These examples is also called as the training data, and we need to predict it for certain new records. Now what is normally done is we need to test the model whether it's working accurately or not in the prediction task. So what we do is, some of these records normally, so some of the records we treat them, some of these example records, we treat them as training data, and the remaining records we treat them as testing data. A few of the records we treat them as testing data, and we assume that we don't have the class label of these records. Okay, and then we use the model in order to predict the class label of these records, and then we compare that predicted class with the actual class, because we actually do have the classes. So we compare the predicted class with the actual class to see whether it's accurate or not. Okay, so that is the basic problem. Now again, this has a whole lot of different applications. Here are just some sample applications. You have lots of applications in text classification, So the first example is about, you need to classify emails as being either belonging to spam or not spam. And this is a very major task because email is a very popular application. In fact, email is the application which made computers very popular. And if email cannot be used well, then there's a big loss. So you need to be able to automatically classify emails as spam or not spam. Okay, so you have two classes there. You have lots of example records. Using the example records, you need to develop a model and do the classification. The second task here is to classify web pages into a Yahoo type hierarchy. So if you had noticed on the Yahoo search page, you will, at the bottom of the page somewhere, you will find a directory hierarchy where different websites are classified into, let's say, computers, business, and so on, different categories. Now, can you automatically classify new web pages into a hierarchy like this? If it has to be done manually, it's a very major task because the web is so huge. You do need a lot of automatic tools for doing this. There are lots of NLP problems, basically natural language processing problems, and things like tagging. Okay, so you want to classify words in a document into whether it's a noun or verb or whatever into the part of speech. So this is a classification task. Okay, and there are many other classification tasks in these areas. Now, one of the major applications of classification where it has been applied in the past is in a whole lot of fraud detection applications. So fraud detection in terms of computer intrusion detection has a hacker come into the computer. What it does is the computer has there's a program running in the computer which actually detects the patterns of usage. Okay, when a normal user is working on the computer, what kind of commands is he normally typing? What is the speed of his normal typing? Okay, so these are different attributes. Okay, and when a hacker comes, obviously the patterns is going to be quite different. The pattern of commands that he's going to use, or the pattern of or his typing speed, these will be quite different. So we can use these patterns in order to detect whether there's been a computer intrusion. Or in terms of credit card transactions, is it the normal user who's using the credit card, or has somebody stolen the credit card and he's using it? Okay, or telecom fraud. Okay, all these different kinds of fraud, can be detected using classification. Then there's a whole lot of applications in machine learning and pattern recognition, and they all use classification type algorithms. Things like in vision, speech recognition, OCR, these kinds of applications. So basically, for example, in OCR, optical character recognition, you have the different characters, printed characters, A, B, C, and so on, and you need to be able to classify. You have the figure, basically it's an image, and you need to be able to classify that image whether it's actually an A, or is it a B, or is it a C, and so on. So that's a classification task. Okay, and the last bullet here is saying that this is not just limited to these applications, but this is a very wide scope of applications here, because all of science and knowledge, if you look at it, it's about predicting the future in terms of what we know about the past. Okay, and it's a kind of prediction. So, and classification basically is doing prediction automatically. So it's using the past data in order to develop a model in order to predict the future. Okay, so it can be applied in any case, in any kind of application. All that you need to do is use your imagination. In any data set that you have, try to convert that data set into a form that is suitable, that is of this kind, where you have a class column, and then you will be able to apply classification algorithms.